welcome to Basics of Finite Element Analysis Part 2. This is the 6th week of this course and today is the 3rd day of the week. Yesterday we had started developing expressions for K matrix elements, and in that context we had introduced some identities which are shown here. So, these are the identities related to a triangular geometry, and these identities are that Imn, which is integral of x to the power of m times y to the power of n times dx dy, and for different values of m and n we had written down these identities. What we had not done was we had not proved these identities because that is not necessarily germane to the theme of this course, but these are standard mathematical identities. If you are interested in figuring out the details, you can explore on the net or in mathematical books and you will find it out. So, what we plan to do is we want to use these identities to develop expressions for elements of S11, S12, S21, S22 and S00 matrices. So, that is what our aim is. So, before we start doing that, we have to recall that psi I for the eth element is what? It equals 1 over twice of AE, which is for the eth element, times alpha I times beta I x plus gamma I y, and all these are specific for the eth element. Please note that alpha, beta and gammas, these are constants. These are constants and they are constants for a specific element. So, for one triangle they may have some set of values, for another triangle their values will be different. Okay. So, if I differentiate psi I with respect to x, then what I get is beta I divided by 2 AE, or what I will do is, so I will omit this E for purposes of brevity because it comes up again and again, and similarly derivative of psi I with respect to y is equal to gamma I divided by 2a. Okay. Now, Sij 11. So, what is S11? It corresponds to del psi I del x times del psi j del x, integral of that. Okay. So, for the for S11 the ijth element is del psi I over del x del psi j over del y, del x dx dy, and my domain of integral is in this case triangle, because we are thinking about a triangular element. Okay. So, we are integrating it over the triangle. So, this del psi I over del x is beta I over 2a, del psi j over del x is beta j over 2a, right. So, it is beta I beta j divided by 2a 4a square integral of dx dy. Okay. So, I have taken these betas. So, this is beta j. So, I have taken these betas out of the integral sign because they are constants. So, I can take them out. Now, this is integral of dx dy, and this is same as I 0 0. right, and the value of I 0 0, if we go back, is A. Value of I 0 0 is A. So, this equals beta I beta j over 4 A. Let us look at S12. So, S12 equals del psi I over del x, and because the second index is 2, so it will be del psi j over del y. Okay. 2 corresponds to y, 1 corresponds to x. So, that is how we figure it out. Dx dy, this equals, so del psi over del x is beta I over 2a, del psi j over del y is gamma j over 2a. So, I get beta I gamma j over 4a square dx dy integrated over the triangle, and what I get from here is beta I gamma j over 4a. Similarly, S21 ij equals beta j gamma I over 4a. And I will also write the expression for S22 directly, and that will be gamma I gamma j over 4a. So, what we have done is we have computed S11, S12, S21, S22, and now we will develop an expression for S00. Okay. So, S00 equals integral over the triangular domain of psi I psi j dx dy. So, 0 implies there is no differentiation. So, what is psi I? Psi I is, we can get what is psi I, we can get the expression from psi I from this relation. So, this is 1 over 4a square alpha I plus beta I x plus gamma I y times alpha j plus beta j x plus gamma j y dx dy. So, this is equal to 1 over 4a square, and I will get, so this is having 3 terms, this is having 3 terms, so I will get a long set of 9 different terms. So, I am going to write down those. So, first I am going to, the term is alpha I times alpha j, that is a constant. Then the next term will involve x, so that is equal to beta I alpha j plus beta j alpha I x. Next 2 terms will involve y, so those will be gamma I alpha j plus gamma j alpha I y. Then we will have a bilinear term involving x y. So, what will be those? Beta I gamma j plus beta j gamma I x y. Then we will have x square term, which will be beta I beta j x square, and then a y square term gamma I gamma j y square dx dy. So, this equals, so let us look at the first term alpha I alpha j times dx dy. So, this means its integral will be alpha I alpha j times I 0 0, right, I 0 0. Then I have this x term. So, this is beta I alpha j plus beta j alpha I, and this constant is multiplied by x times dx dy and it is integrated. So, this will give me I 1 0 plus the third term gamma I alpha j plus gamma j alpha I, and this is multiplied by y times dx dy. So, integral of y times dx dy is I 0 1. Okay. Then I look at the fourth thing. So, this is beta I gamma j plus beta j gamma I, and that is multiplied by x y, and if I integrate x y dx dy over the triangle, I will get I 1 1. And then I have beta I beta j, and integral of x square dx dy will be I 2 0, and then finally I have gamma I gamma j I 0 2. Okay. So, I will write this again 1 over 4a square. I 0 0 is, what is the value of I 0 0? It is a. Then value of beta I alpha j plus beta j alpha I, and the value of I 1 0 is a x hat, a x hat. Then the third term gamma I alpha j plus gamma j alpha I, and its value is a y hat plus beta I gamma j plus beta j gamma I, and the value of a I 1 1 is a by 12, and so x I So, it is a long expression, but you can plug in there. So, I will at this stage I will just leave it as I 1 1, but you know what is the expression for I 1 1 plus beta I beta j I 2 0 plus gamma I gamma j I 0 2. Okay. So, this is S 0 0 0 I j. So, using this relation you can calculate S 0 0. Okay. So, now we know how to calculate S 1 1, S 1 2, S 2 1, S 2 2 and S 0 0, and once we are able to calculate these, then we can use these things to compute all the elements of the K matrix with the assumption that A 1 1, A 1 2, A 2 1, A 2 2, A 0 0 are constants. So, that is about the K matrix. The next thing is about the elements of force vector. So, that is another thing we will see. So, force term. Okay. So, we had written that Fi equals integral over the domain f times psi I dx dy. Okay. Now, again if f is constant, then it will be f, this small f is constant, then it will be integral of psi I dx dy, and this is equal to, what is psi I? Psi I is alpha I plus beta I x plus gamma I y dx dy, and this here we are integrating it over the triangle. This expression can only be put for a triangular domain. So, that is why I have to replace omega by triangle. Okay. So, this is equal to, and there has to be also a 2a in the denominator. So, this is equal to f by 2a integral of alpha I dx dy is alpha I times a, integral of beta I times x dx dy is beta I times a x hat, and integral of gamma I y dx dy is gamma I y hat a. So, a goes away, f by 2 times alpha I plus beta I x hat plus gamma I y hat. Okay. And there is another mathematical identity which tells us that alpha I plus beta I x hat, and you can do the mathematics and you will find out that it is true, plus gamma I y hat equals 2/3 of the area of triangle. So, what I get is f times a divided by 3 f I. So, what does it mean? That if I have a triangle, if I have a triangle and I am putting some force per unit area, so I am putting some force in the norm. So, the triangle is, let us say here, and I am putting some force per unit area, and the intensity of that force is F. So, its units are what? If it is force, then it will be Newton per square meter. In other problems, for instance, in case of diffusion and other things, it will be somewhat different, but if we are talking about mechanics, then if it is force, then force per unit area. So, then the total force will be what? Which will be exerted upon the triangle will be F times A, right? And there are 3 nodes, 1, 2 and 3. So, for the ith node, the total force which will be exerted on the ith node will be 1/3 of that total force. Do you understand that? So, F1 plus F2 plus F3 equals F times A, where A is the area of the triangle, and each node shares equal amount of load. Each node shares equal amount of load. So, this is the physical interpretation of this mathematics. So, now we know how to calculate the force term and also the terms for K matrix. What we will do in the next class is we will continue this discussion, but what we will do is, what we have done till so far is we have calculated these terms for a triangular element. What we will now do is we will also do similar mathematics for a 4-noded rectangular element, so that we get comfortable with this whole idea. So, that closes the discussion for today, and tomorrow we will continue this and we will apply all this understanding to a 4-noded rectangular element. Thank you very much. Bye.